You check your phone before heading out, hoping to see a simple sun emoji. Instead, the screen lights up with a blaring flash flood warning. It is easy to assume the company that made your phone, or the developers who built your favorite weather app, somehow predicted this storm themselves. But Silicon Valley doesn't predict the weather. Apple, Google, and independent app makers aren't launching weather balloons or running private global forecast models. They are pulling their information from the exact same central source. Here in the United States, that central source is the National Weather Service. It is a government-funded engine that provides a massive well of atmospheric data entirely for free. If your app is just putting a cosmetic layer over someone else's homework, how does raw, invisible atmospheric chaos actually get translated into a life-saving alert on your screen? Before anyone can predict what the weather will do tomorrow, they have to observe exactly what it is doing right now. This diagram shows a Doppler radar station in action. The dish emits bursts of energy hundreds of times a second, but most of the time it's just listening for the tiny fraction of energy that scatters off objects and bounces back. When those returning waves shift in phase, computers calculate the speed and direction of the target. This Doppler shift tells meteorologists if an echo is a harmless rainstorm, a rotating tornado, or even a flock of migrating birds. Collecting these physical echoes is the essential first step, but raw observations alone cannot tell us what happens next without mathematical context. Knowing it is raining over a specific county right now doesn't tell you where that rain will be in 3 days. Those observations have to be fed into massive mathematical models. The U.S. government runs this incoming data through supercomputers, using systems like the Global Forecast System, or GFS. They compute the complex fluid dynamics of the atmosphere and release the results to the public for free. You might hear that the European model is slightly more accurate, which is largely due to focused funding on a single primary model. But accessing that European data costs money, making the free American models incredibly valuable. This diagram shows the true output of these models. Supercomputers do not spit out a sunny emoji. They generate a dense, terrifyingly massive grid of raw numerical values spanning the entire globe. This is where the private sector steps in. Tech companies download this free grid, slice it up, apply their own algorithms to correct for historical biases, and design the sleek interfaces you interact with. The app you rely on every morning is simply the final cosmetic layer wrapped around a colossal, publicly funded mathematical engine. This data pipeline extends far beyond your daily commute. It serves as critical infrastructure for people navigating some of the most extreme, disconnected environments on Earth. Imagine navigating a cargo ship through the middle of the ocean. You have no mobile reception and no access to the internet, but you urgently need to know if a storm is forming ahead of you. Mariners rely on a system called Navtex. It is a mandatory piece of radio equipment that automatically prints out highly formatted, localized weather warnings tapped directly from the global data chain. Look at this image of a traditional sailing frigate. Modern maritime forecasts still use historical frameworks based on ships exactly like this. Instead of raw wind speeds in knots, they use the Beaufort scale, which originally described how much sail a frigate could safely hoist, preventing dangerous confusion over a crackling radio. Even legacy, offline maritime technology relies entirely on the exact same modern data supply chain to keep crews alive. Because weather impacts almost every aspect of human life, this system generates massive economic value. It is the original form of big data, and corporations use it aggressively for risk management. Global logistics giants like DHL monitor this data continuously. When a volcano in Iceland erupted and filled the sky with a dangerous ash cloud, they used real-time atmospheric data to dynamically route thousands of flights out of harm's way. Retailers track the models to predict exactly where a blizzard will strike, allowing them to pre-position high-demand recovery inventory, like snowblowers, in the exact neighborhoods that will soon look like this parking lot. Pharmaceutical companies analyze temperature and moisture predictions to forecast when an unusually cold spring will delay allergy season, adjusting their supply chains to stock medications precisely when the pollen finally spikes. The next time you check your phone for a simple weather emoji, remember what you are really looking at. You are seeing the endpoint of an invisible, free global infrastructure that protects lives, guides cargo ships and drives the entire world's economy.